Looking at page 10 in your guided notes packet, number 3, we have a 100-meter long wire with a resistance of 10 ohms. What would the resistance of each piece of this wire be if it were cut into 4 equal length sections? Well, the first thing that we need to think about is what kind of relationship is resistance and length? Resistance and length are on opposite sides of your equal sign. They both are in the numerator. Therefore, they have a direct relationship. So, if your length decreases by 4, so would your resistance. 10 over 4 ohms, or if you simplified, 2.5 ohms would be your answer. For number 4, a 0.02 meter long carbon resistor with a cross-sectional area of 2 times 10 to the negative 6 meters has a resistance of 300 ohms. What would its resistance be if its length were doubled? Well, again, resistance and length have a direct relationship, so if length increases by twice as much, so would your resistance. So 300 doubled gives you 600 ohms. For letter B, what would its resistance be if its cross-sectional area were tripled? Well, if I look back at my formula, R equals rho L over A, if my area is tripled, that means that my resistance and my area have an inverse relationship. They're on opposite sides of the equal sign. Resistance is in the numerator, area is in the denominator. So if my area triples, opposite would be for my resistance. So my resistance must decrease by a factor of 3. So 300 ohms divided by 3 gives me 100 ohms as my answer. For letter C, what would its resistance be if its radius were doubled? So when we're doing this, if you look at your formula, R equals rho L over A, nowhere in that formula is radius. However, we know that area of a wire, area of a circle, is pi r squared. So that's where my formula here comes from, A equals pi r squared. So I could really replace my formula, R equals rho L over A, with R equals rho L divided by pi r squared. They're equal, they mean the same thing. So the first thing you need to do is think about, well, what happens to my denominator? Well, if I double my radius, that means that I'm squaring my r, so 2r squared, which means that I have 4 times as much in my area denominator. If my denominator increases by 4, that means that my resistance must decrease by 4 because they are inversely related. So 300 divided by 4, if you simplify, you will end up with 75 ohms. So that's page 10. I also asked that you did page 11, and here is page 11. So we're going to just do a couple of these, and I apologize for the crossing out of the for number 3, but you definitely can see the answer that would be in purple. So just looking at a couple of these. So for instance, number 1, see if we can zoom in here. So number 1, we have, what is the resistance of a copper battery cable, 6 millimeters in diameter and 42 centimeters long at 20 degrees Celsius? So first of all, we first need to solve for our length, converting it to meters. So that's where this comes from right here. So 42 centimeters, I want to get rid of centimeters, so centimeters must go on the bottom of your next fraction. There are 100 centimeters in 1 meter. I can solve for it this way. I will always tend to put all of the work into one equation. You do not have to do that. You can definitely separate it if you want to have multiple equations because it's easier for you to visualize. That's totally fine. The other thing that you need to do is also convert, or not convert per se, but to solve for your area. They tell you that your diameter is 6 millimeters long, or wide, I should say. So with that, your area formula, A equals pi r squared. Pi times, they tell you your diameter is 6 millimeters, which means that your radius must be 3 millimeters. You have to make sure you convert millimeters to meters. There are 10 to the negative 3 meters in 1 millimeter, coming right from your reference table on the first page, bottom left, your conversions chart. Squaring your radius. For your radius value, you should have ended up with 2.83 times 10 to the negative 5 meters squared. If you did not get that, go back and retry it. chances are you may have had a parentheses issue. Just go back and retry it with your calculator. Once you have all of those different components, you can then go ahead, plug it into your formula. This right here comes from your reference table. They tell you that this is a copper battery. Copper, your material. Look right on page 4 at your resistivity chart. You will see this value right here under copper. Plugging everything in, you have to make sure, again, you use parentheses. To reiterate, your area on the bottom, the 2.83 times 10 to the negative 5 meters squared is your unit. The square does not apply to the number, so please, please, please be careful. Your final answer, if you did this correctly, 2.55 times 10 to the negative 4 ohms. A lot of these worked with solving with conversions. We need to make sure that you can do that to convert. A lot of the questions that you will see in the future, whether it be on the Regents, on exams, will have a component of converting. You know we've been doing that all year, so that definitely isn't going anywhere. It will also always tell you 20 degrees Celsius, because if you look on page 4 at your resistivity chart, it tells you that it says the resistivity values at 20 degrees Celsius. So it's just telling you that so that you know you can use those values on your chart. The 20 degrees Celsius doesn't have anything to do as far as mathematically how to solve for these problems. As far as the work for these, I will zoom out so that you can hopefully see this as a whole here. When we have our extra help Google Hangouts, if you have any questions on this, definitely make sure to ask. A lot of this is just making sure that you can go through, solve with these components individually, and then plug it back in.